Hello, everybody. This is Mr. Dale Campo. This is the Wednesday and Thursday, December 9 and 10 lesson. Some of you have us on Wednesday, some of you have us on Thursday. What we're going to do in this video is we're going to review what happened in Zoom class. And we're also going to take a look at several ways to do one of the problems from this assignment. Actually, we're going to, the nice thing about this video is we're going to go in deeper details on number 2. And hopefully you'll see different ways to do number 2. And hopefully that can inspire you to complete the rest of the problems in this assignment. All right, so here we go. So we're going to recap what this lesson was about on Zoom. There was a do now activity. And the do now activity looked like this. And the nice thing about our do now activities so far is it's really about what you see. What do you see? What do you notice? And what do you think about? Or what do you wonder? Okay? So you can notice and wonder a lot of different things. And so just go for it. Whatever you're thinking, whatever you're seeing, put it on the page, okay? And what Mr. Zuniga did is he actually showed us some of the things that you can see, okay? So here are some possible things to also notice about, okay? And that doesn't mean that this is the right answer, okay? Whatever you notice and wonder, put it down, okay? Now, in terms of 1B, how do you think the dots are related to the numbers? Here's how you can kind of think about that, okay? For every 4 blue dots, 1, 2, 3, 4, there are 12 total. I bet you if you count this, you'll notice that there are 12 total, okay? Here's another one. For every 1 green dot, there are 2 blue dots. So here's 1 green dot, 2 blue dots. Here's a 1 green dot, here's another green dot, and here's another 2 blue dots. So it truly is, for every 1 green dot, there are 2 blue dots. So that's why you see these ratios as well, 1 to 2. Here's another ratio, 4 to 12. Okay, so those are things that you can talk about here as well, okay? But remember, it is how do you think, okay? So you may have different answers, and that is totally okay. So that was number 1, and we did that as a class. And we also looked at some of our classmates' answers for that. Then we talked about how feedback on the milestone task has now been posted. Okay. And we'll take a look at a document that shows you what that feedback looks like. I do recommend watching this video. It'll explain the feedback process. And basically, with the grading period ending next week, there is a deadline to fix your task, and this is a temporary deadline. Okay, do watch the video in the slides. So these are the Google slides. Please go watch that video. It'll explain it more. Okay, so you want to work on that assignment as well. Here's what the feedback document looks like. Okay, so every student has their own file. Please take a look at that file so that you can revise your work. They'll tell you your point totals for each. This lesson today was about solving ratio problems with the help of tables, with the help of tape diagrams, or using other ways. So we're looking at 3 different ways: tables, tape diagrams, or other ways to solve ratio problems. And this lesson was real-life ratios with percents. So there were a little bit of percents in these problems as well. Now, Mr. Zuniga did an awesome demonstration with colors. So we're going to go to a website called trycolors.com. And we are going to try mixing different types of colors together, okay? And I'm actually going to demonstrate this with different colors, okay? So let's pretend we're going to put together, let's put together 2 drops of yellow. Here's 1 drop of yellow. Here's another drop of yellow. That was 2 drops of yellow. So 2 drops of yellow. Now, I'm going to put, let's put 4 drops of green. Let's see what happens. Here's 1 drop of green. Here's another drop of green. It's getting darker. 3 drops of green, 4 drops of green. Okay? So I just put 4 drops of green. We'll go ahead and paint the boxes too. Here's yellow, here's green. Okay? Now, pay attention to the unique color that I came up with. So this is the color we came up with. And this is just a special code that came with that color. Okay? So I'm going to save this. I'll press save right here. And it saves this to this palette. Okay? So this is the special color we came up with. All right, now I'm going to go back to our mixer. And I'll just go ahead and make this a little bit bigger so we can all can see this a little more clearly. All right, so 2 drops of yellow plus 4 drops of green came up with this color right here. What if I wanted to make more of this color? Okay, what if I wanted like a full bucket of this color so I could paint my room? Okay, what would I need to keep on doing so that I can get more of this color, right? So what Mr. Zuniga eventually demonstrated was that if I want more of this color, well, then I just need to keep repeating the ratio. Okay, so meaning that to get more of this color, I would have to do the same thing. So the first time I did 2 drops of yellow, well, I'm going to add another 2 drops of yellow. 1, 2, and so wait, let's stick to the yellow first. Okay, so now I have 4 drops of yellow. Okay. Right, now I have 4 drops of yellow. All right, now what do I do for green? I put 4 drops the first time. What do I do now? Well, I got to do 4 drops again. 1, 2, 3, 4 drops. Now I have 8 total drops of green. So I'll put 8 total drops of green on my table. This is a table. Tables are really good for ratios. Okay, so here's my awesome table. Right? Now let's see. Do I have the same green as I had before? Okay, well, let me go ahead and press save. Oh, hey, it's already in the palette. Meaning, yes, I have the same green. Okay, I have the same green. All right. Let's try something else. Will I have the same color? Will I have this same color if I just added 2 over here and 2 over here? Will I have the same color if I add 2 over here and 2 over here? Let's try it. Okay, so I'm going to add 2 over here. How much yellow do I have now? 6, right? All right, now I'm going to add 2 over here. 8 plus 2 gets me 10. But here's my question. Here's a question. Do I have the same green as before? Do I have the same color as before? Let me save it. And now let's go ahead, take a look at our palette. Is this the same as this? And if you look at it, they look very close, but they're not actually the same. And looks like on my, so you can tell they're not the same because the codes are not the same. And since the codes are not the same, this is definitely not the same color, okay? And it looks like this color is a little bit darker, okay? This part is, this is darker than this, okay? So 6 and 10 cannot work, okay? This does not work. And in fact, maybe I'll just put a big X on there. Let's see if I can do that. So this cannot work out. Can't do that. We're not allowed to just add 2 and add 2 because they're not the same. We're not going to get the same color we want, okay? But we can keep the pattern going. And the pattern is basically this. If you put 2 drops of yellow, you got to put 4 drops of green. Let's repeat that. I can add another 2 drops of yellow. And if I add another 2 drops of yellow, I got to add another 4. Okay? And basically, if I want to continue this pattern, I got to keep on adding 2. What's 4 plus 2? Oh my gosh, let me use my pen. Actually, let me just change my microphone real quick here. Okay, so this is what we're talking about. What we're trying to say is that for every 2 drops of yellow, you have to add 4 drops of green. So for every 2 drops of yellow, you got to add 4 drops of green. 2 drops of yellow, 4 drops of green. 2 drops of yellow, 4 drops of green. 2 drops of yellow, 4 drops of green. 2 plus 2, 4. 4 plus 2, 6. 4 plus 4, 8. Plus 4 again, 12. Okay? Wait, does that make sense? 6 drops of yellow, 12 drops of green? Let's try it. So I'll remove this because this was wrong. Let's remove it real quick. Let's try it. Oh, remove. Okay. So let's go back and see if we can see if this is right. Is 6 drops of yellow and 12 drops of green correct? Let's try it. 6 and 12. Here's 6 drops of yellow, 12 drops of green. Let's take a look. Hey, it's the same thing. It's already in the palette. So yeah, this is correct. Okay. Again, look back at what we did originally. We started with 2 drops of yellow, 4 drops of green. So we're going to add another 2 drops of yellow. And we're going to add another 4 drops of green. So we get 8 and we get 16. Okay. And if you try that too, 8 drops of yellow, 16 drops of green. Whoops. Whoa, too much. Yes, it's the same thing. Okay. So that's a color demonstration with ratios. If you want the same color, you got to keep the ratios the same. 2 for every 4. 2 drops of yellow for every 4. 2 drops of yellow for every 4. 2 drops of yellow for every 4. Okay? Keep the ratios the same. And Mr. Zuniga also talked about the power of for every. Okay? One great way to remember ratios is to think of the word for every. For every blank, there is blank. Okay? And you see this You see this for every in Arduino, right? We reminded you all that there is the 3-read protocol. Okay, it's a great way to remember word problems. I mean, it's a great way to solve word problems, especially when there are a lot of words. Okay, so we talked about taking a word problem and reading it 3 times or more if you want to understand it. We talked about circling important information. We've talked about underlining the question. Okay, so those are things you want to think about. Those are things you want to do when you especially get to difficult word problems. This is what it can look like. All right, and those are the steps right there. By the way, you all have access to these slides if you want to look at it in more detail. We then got into our breakout rooms. Okay, and we limited the assignment to a certain number. I believe we stopped at, we only told you all to do 1 to 7. Most students finished number 2 in breakout rooms. And if you're watching this video and you might be thinking, oh my gosh, hey, I already did number 2. Well, that's cool. But we're going to talk about different ways to look at number 2. Okay. And these different ways of doing number 2 can be helpful for the rest of the problems you will do with ratios. Okay. So bear with me here, even if you've already done this. You might be amazed by all the different ways you could do this problem. Okay. Florida florist arranges flowers in vases for table decorations. Okay. So a vase is like a container. All right. Here's a container. So here's a vase. Oops. Well, it's just one vase, not 2. Florida florist arranges flowers in vases for table decorations. And by the way, a vase is also a table decoration. She always uses 2 roses and 3 carnations in each vase. Okay, so that's one way to highlight, to circle important information. I've also seen people just circle the entire sentence. And that word always is really helpful. Okay. Flora has 20 roses. How many table decorations can she make? How many carnations will she use to make these table decorations? Okay. So remember, this is a reading strategy. Circle important information, like I did, and underline underline what the task or the questions are. Okay. What is one way to do this problem? Some of your classmates were using multiplication and some of your classmates were using division. But I want to point to a very powerful way to do this problem. And it is one method that we were looking at in an earlier assignment this week. You all had a Monday, Tuesday, Wednesday assignment earlier this week on tables, ratio tables. Okay, so tables can look like vertical. They can look like vertical tables, which go from top to bottom, or they can look like horizontal tables that go left to right. Okay, for this demonstration, you can do tables in any way you want, but I'm going to do the vertical table, the table that goes from top to bottom. Okay, now, oh no, did we just lose all the things that I had written down? It's okay. I can just do it again here. Okay, so always when you do a table, so we're going to solve this table way. Always when you do a table, just think about how would you put the heading. So here I'm going to put roses. I'm going to put carnations. Okay. And now just one thing to keep in mind is it's okay to do shortcuts. So just to do shortcuts, I'm going to say R is for roses and C is for carnations. Okay. Let's go back to the problem to get the important information. She always uses 2 roses and 3 carnations. So let's put that on our table. She always uses 2 roses and 3 carnations. But, all right, she always uses 2 roses and 3 carnations. And Flora has 20 roses. How many table decorations can she make? Wait a minute. So we already put this information, and we already put this information. And I know Flora has 20 roses. So where should we put the 20? Should we put it here? Or should we put it here? Well, since we're talking about roses, we'll just keep it in the R column for roses. R is for roses, okay? How many table decorations can she make? Wait, what? They're talking about table decorations. Okay, well, remember what we also said earlier. Here's a vase. Okay, this is our vase. And every vase has 2 roses. Oh my gosh. Every vase has 2 roses. Let's make that nice. Every vase has 2 roses and 3 carnations. This is the table decoration. Okay. All right. How many table decorations can she make? What? We got to figure out table decorations. Okay. Now, another thing to keep in mind, if it helps you, is we can draw a 3rd column. You don't need to, but if you want to, you can draw a 3rd column. This is going to be our table decoration column. Okay. 2 roses, 3 carnations. That's 1 vase. That's 1 table decoration. Look at the picture. 2 roses, 3 carnations. That's 1 vase. That's 1 table decoration. Well, what if we had 2 table decorations? How many roses and carnations are in 2 table decorations? Well, remember, you always got to put 2. Flora always uses 2 roses and 3 carnations, so this would be 4 and 6. How did I get 4 and 6? Well, remember, you can see a pattern right here. I added another 2 roses, and over here, that doesn't seem dark enough. It makes me worried. So I added another 2 roses here, and I got to add another 3 carnations here. Okay. Wait a minute. Flora has 20 roses, so I have to get to 20. I have to keep on going until I get to 20. Okay? And once we get to 20, we can figure this out. All right, let's keep going. All right, if I had 3 table decorations, how many roses and how many carnations would I have now? How many roses and how many carnations would I have now? Well, this involves adding another 2 roses and adding another 3 carnations, because it's always 2 roses and 3 carnations in each vase. All right, 6 roses, 9 carnations. Okay. And basically, if I keep this pattern going and I try to get to 20 roses, I can keep on adding 2 over here, add 3 over here, add 2, add 3, add 2, add 3, add 2, add 3. And by the way, Let's make sure we're not messing up. So drawing those lines in the table is very helpful. Add 2, draw that line. Add 3. Am I done yet? Am I done yet? No, because Flora has 20 roses. Okay. Add 2, add 3. Running out of space. Add 2, add 3. All right, now I'm officially done. Let's see. Okay, Flora has 20 roses. Check. Yes, 20 roses are here. Did I put 2 roses and 3 carnations? Yes, I kept it 2 to 3. 2 for every 3. 2 for every 3. Add 2, add 3. Add 2, add 3. Yes, I did. Okay, so now can I answer this question? How many table decorations can she make? How many table decorations can she make? Well, let's look at our table. How many table decorations can she make? It's 10. Okay, she can make 10 table decorations. Okay? Tables are one way to do this problem. Okay? However, some of your classmates, again, used other ways. We've seen some of your classmates use multiplication. We've seen some of your classmates say multiplication works. Okay? So another way, by the way, this is the first way. Another way to have done this problem is to say, oh, hey, it's 2 roses right here. I marked that in red. 2 roses. And Flora has 20 roses. Okay. 3 carnations. Oh, and what the very interesting thing is that this actually covers. So, sorry. Forget what I just said. All right. So, hold on. Well, to go from 2 roses to 20 roses, to go from 2 roses to 20 roses, I should stay with red. To go from 2 roses to 20 roses is times 10. To go from 2 roses to 20 roses is times 10. So therefore, the answer to 2A, how many table decorations? How many table decorations? It's 10 table decorations. Okay? So, first way, draw a table and you get 10 table decorations. Or, second way, multiplication. Okay? If you don't see the multiplication right away, just do a table. Now, here's another fun thing to think about. How is the second way similar to the first way? How is the second way similar to the first way? And here's another hint for that question. How do you see times 10? How do you see times 10 in the table? Okay, watch this. 2 times 10 is 20. Well, let me mark that on my table. 2 times 10 is 20. This 2 times it by 10 gets you to 20. Well, if I take the 1 table decoration and I multiply times 10 also, times 10, you also get the 10 right there. Okay? So you can see how the second way is connected to the first way. You can see how the second way is connected to the first way. All right? Now, that is 2A. All right? How would you figure out 2B? How would we do 2B? The cool thing about 2b is you could use the table also. It says here, how many carnations will she use to make the table decorations? How many carnations will she use for those table decorations? It's right here. How many carnations? 30 carnations. Okay? She will use 30 carnations. We already did it. It's on our table. Okay, it's right here. Okay? But how would you do that with multiplication? Some of your classmates came up with this. Well, it's 3 carnations, 3 carnations, and, well, we already know there's 10 table decorations, so there's 10 table decorations, so it's just times 10, and we get 30 carnations. Okay? So, same thing here, 30 carnations, or 30 carnations. All right, so that is number 2. We did this the table way. We did this with multiplication. Some of your classmates use division, and I'm saying all of that because you can use any of those tools to take care of the next problems. Okay? Think of multiplication, think of division, think of repeated addition. And this is what really, when you see a lot of ratio tables, it is a lot of repeated addition. Plus 2, plus 2, plus 2, plus 2, plus 3, plus 3, plus 3, plus 3. Okay? So use those tools. In a previous lesson earlier this week, we also talked about tape diagrams. You can also use those as well. Okay? So hopefully this video helps you out. And as always, if you need any more advice, please do contact your teachers. We are more than happy to help you. Hope you all have a wonderful day. Take care, everybody. Thank you.